Hello guys, so for this video, I will be discussing acid-base balance. Okay, so first, of course, we have to review the basic, diba? The basic things about this particular topic. So in the board exam recently, they get questions from the introduction part, okay, of every topic included in our references. So basically, for acid-base balance, I would recommend that you read Bishop. Okay, I would recommend that you read Bishop, the discussion on acid-base balance. And again, do not skip the introduction part because lately they have been getting a lot of topics, okay, or a lot of questions rather from the introduction part, okay? Yes, so what is the goal of your acid-base balance? What is the ultimate goal of your acid-base balance? So later we will answer that. So before we go to that, before we go to harder topics on acid-base balance, so let us try to review some basic terms which you have to know when it comes to this topic. Okay, so let us have a review of the definition of terms on acid-base balance. Okay, so according to Arrhenius, yeah. Okay, so this was actually asked already in the board exam, January 2021, if I'm not mistaken, or March 2021. Basta nung 2021, tinanong tong tanong na to. Okay? So substance that can yield hydroxyl ions when dissolved in water. So do not forget, that's your base. Okay? So actually, this is naman general knowledge, diba? It's a basic knowledge that we learn as early as our general chemistry. Okay, so remember our base, diba? Our bases, these are substances that contains hydroxyl ion or our OH. Okay, like for example, potassium hydroxide, we have KOH, sodium hydroxide is NaOH. Okay, so all of these are bases. And of course, when they are dissolved in water, they will yield or they will release hydroxyl ions. Okay, ayan. So according to Henry, bases, so these are substances that increase the concentration of hydroxyl ions when dissolved in water. Okay, so however, based on, yes, the recall question that I got from our examinees, so ito yung nilabas nila. Okay, substance that can yield hydroxyl ion, base. Okay, another important term, we have acid, so substance that can yield hydrogen ions or hydronium ions when dissolved in water, so that would be your base. Of course, we are very much familiar of our hydrogen ions, right, being liberated when an acid is dissolved in water. However, please also do not forget your hydronium ion or your H3O+. Okay, so this one may also be formed, diba? This one may also be formed when an acid is dissolved in water. Okay, another recall question from the board exam is the definition of a buffer. Okay, yes, a buffer, take note, it consists of a weak acid, yes, and its salt or conjugate base. So it may also be defined as a weak base and its salt or conjugate acid. Okay, so what was asked in the board exam, or one of the choices that came out in the board exam, is that buffer is a weak acid or a weak base and its salt. Okay, so it is a weak acid or a weak base and its salt. This is the definition that was given by Bishop in the 5th edition. However, if you're going to read the recent editions of Bishop, so the definition was already changed to weak acid and its salt or conjugate base. Okay, yes. So please take note, ha. Yes, from what I have observed when it comes to the recall questions that we get, they have read, okay, they have read both the 5th edition and the 7th edition. Okay, so for the 7th edition, so please read your Lean Six Sigma. Yes, read also the Lean Six Sigma from your Henry's. Anyway, it's just a very short, chapter or topic in your Henry's. Okay. Yes. So when it comes to the definition of buffer, so do not forget the definition given in the 5th edition. So weak acid or weak base and its salt. Okay, so this was the one, or this was the recall question from 2021. So as you can see from the introduction part only, from the definition of terms alone, so there were already two, diba? There were already two questions that were given in 2021. So from this definitions alone, so we have the definition of a base and then the definition of a buffer. Okay, so now let's move on. We have your, yes, still under the introduction part of your acid-base balance. Okay, so of course, it's very important for us to know your Henderson-Hasselbach equation. Okay, yeah, so your Henderson-Hasselbach equation. So this is actually an equation for the computation of pH. Okay, so this is an important, yes, this is an important computation for your pH. Okay, so what are the things that we have to know about your Henderson-Hasselbach equation? So for the formula, specifically, pH is equal to 6.1. So 6.1, this is actually the acid dissociation constant. Okay. Yes, this is your acid dissociation constant, or your pKa. And then plus the logarithm of the concentration of your bicarbonate, and then divided by the partial pressure of carbon dioxide times 0.03. Okay, times 0.03. All right. So actually, the denominator, okay, the denominator in your Henderson-Hasselbach equation, so this may be changed to the concentration of your carbonic acid. Okay, so basically, partial pressure of carbon dioxide times 0.03. So this is equivalent to the concentration of your carbonic acid. Okay, so if we are going to look at your Henderson-Hasselbach equation, okay, so the numerator, yes, favorito nila. Lumabas na ba ito? The numerator, which is represented by your bicarbonate, okay, by your bicarbonate. So this is your, wait lang class ha, this is your bicarbonate, okay, your bicarbonate. So that is the variable that is found in the numerator of your equation. And then at the bottom part, you would be able to see there the partial pressure, diba? Partial pressure of carbon dioxide, okay, of your carbon dioxide or your carbonic acid, okay, or your carbonic acid. So I repeat ha, partial pressure of carbon dioxide, this is not your carbonic acid, okay? So you have to multiply first the partial pressure of your carbon dioxide by 0.03 in order for it to, yes, in order for you to be able to know the concentration of your carbonic acid. Okay, nonetheless, if you are going to look at, yes, if you are going to look at the equation, diba? Partial pressure of carbon dioxide or carbonic acid, this is the one that is in the denominator. Tama po yung spelling ko, denominator. Denomination. Denominator. Okay, so it is the one that is in the denominator. So, yes, what was the question given in the board exam? So, what organ daw or the denominator in the HH equation represents blank function. Okay, so ganun po yung tinanong. The denominator in the HH equation is or represents blank function. Okay, so what particular what particular organ rather is represented by the denominator daw. Okay, so basically ganun yung tanong. So take note that since the denominator contains the variables for your partial pressure of carbon dioxide or your carbonic acid, so the denominator basically represents your lung function. Okay, so it represents lung function. In contrast, if you're going to look at the numerator, so it contains the bicarbonate variable, right? So concentration of your bicarbonate. So this means that the numerator indicates kidney function. Okay, so it is the one that represents your kidney function. Okay, so yan. So ito po, di ba? Bicarbonate, concentration of bicarbonate, partial pressure of your carbon dioxide. Okay, so in short, if we are to look at the organs that are responsible for your acid-base balance, then we are referring to your lungs and your kidneys. Okay, your lungs and your kidneys po. All right. So take note that the lungs, so they exert their control over your acid-base balance by, di ba? By modifying the concentration of the partial pressure of carbon dioxide. Okay, yes. And then your kidneys on the other hand, so they exert their acid-base balance function or their function in acid-base balance by modifying the concentration of bicarbonate inside the body. Okay, yes. All right. So another basic thing that you have to remember, simplehan lang natin para at least mas matandaan natin. So pag lungs, ang kinokontrol niya ay carbon dioxide. Pag kidneys, ang kinokontrol niya ay bicarbonate. Okay? What will be the effect of your carbon dioxide to your body? So take note that carbon dioxide makes your body, makes body, yan, CO2, take note, makes the body acidic. Okay, it makes the body acidic. So of course, you don't want your body to be acidic, right? Yes, of course. So that's why there is a mechanism by which your body is able to get rid or to excrete your carbon dioxide. And what is that mechanism? By breathing, di ba? Okay, so your body, if it's too acidic, particularly if you are suffering from metabolic acidosis, so the compensatory organ would be the lungs, right? And then what will your body do? Your body will exhale more carbon dioxide by asking you to breathe more or by making you breathe more, di ba? Like that, okay? So yeah, it's like that, okay? Yeah. So later we will talk about that. Ang gulo ko talaga. Okay. Next naman. So we have to understand also, or we also have to identify what is the effect of your bicarbonate inside the body. So take note that bicarbonate makes the body basic or alkaline. Okay? So it makes the body basic or alkaline. Yes. So when we talk about, di ba, your acid-base balance, take note that the goal of the body, Di ba? Ano ba ang goal ng body natin? To balance. Yes. So of course, we have to take it to a higher level. Specifically, what balance are we trying to say here? So balance in your pH. Di ba? So what is the normal pH of the body? So we have 7.35 to 7.45. So basically, when we talk about your acid-base balance, so this would involve mechanisms, diba? Mechanisms utilized by the body in order to maintain the pH at 7.35 to 7.45, okay, which is the normal pH, diba? That's the normal pH po. Depending upon whether your body is in a state of acidosis or is in a state of alkalosis, so your body will respond to this particular imbalance via your lungs or your kidneys, depending upon the problem. Okay, so since we are talking about problems, let's take a look at the different, let's take a look at the different imbalances. Okay, yes. So take note, class. So just to make it simple, take note, an increase in pH. Increase in pH. So that means greater than 7. If your pH becomes greater than 7, then you are in a state of alkalosis. Okay, yes. Increase in pH means the pH is alkaline or basic. So, kailan? When? When will you be in a state of alkalosis? If there is an increase in your bicarbonate or a decrease in, okay, so this one or a decrease in your carbon dioxide. Okay, so I repeat, you are in a state of alkalosis if there is an increase in your bicarbonate. Remember, di ba? Your bicarbonate makes your body alkaline. Okay? Carbon dioxide, on the other hand, will decrease. So if there is a decrease in carbon dioxide, so of course, this will also lead to alkalosis. Okay? A decrease in pH or the body is in an acidic state if pag decrease in pH meaning less than 7. Okay? However, sige, lagyan natin ganito. Ano ang normal pH ulit natin? 7.35 to 7.45. Alright, sige. Tayo dyan mamaya. Okay, so an increase in carbon dioxide and a decrease in bicarbonate. So remember, what will be the effect of your carbon dioxide inside the body? Yes, it will make the body acidic. And as such, if this would be the conditions, so your body will be in a state of acidosis. Okay? Yes. Take note, class, that our basis in determining whether your pH is acidic or basic, or if you are in a state of acidosis or alkalosis, would be the normal pH range, which is 7.35 to 7.45. Okay, yes. So kindly disregard what I said a while back because I think I mentioned that greater than 7 and then less than 7. So that is in environmental conditions, diba? I mean, like outside in vitro, outside the body. So our basis, of course, would be the neutral pH, which is 7. However, if we are talking about in vivo, which is usually the case, of course, when we talk about your board exam, what we consider is the normal value of your pH inside the body, and that's 7.35 to 7.45. Okay, so let's define now, or let us quantitate your alkalosis. So your alkalosis, class, so this happens if the pH is greater than 7.45. Okay, so that is already alkalosis, or your body is in a state of alkalosis already. Okay, so however, if the pH, on the other hand, if the pH is less than 7.35, okay, if the pH is less than 7.35, then your body is already in a state of acidosis. Okay, so ganun siya ha. Ayan, alright. Okay, okay, sige. Punta tayo sa compensation. Okay, yes, punta tayo sa compensation. All right? Or sa imbalance rather. So let us discuss further imbalance. Okay, ayan. So basically, when there is acidosis, okay, when there is acidosis, or wait lang, when there is an imbalance, ito muna, so that, wait, saan ko ilalagay kaya ito, Besh? Ibang whole na lang, ganyan na lang. Okay. Wow. Dapat 30 minutes ko lang to. Alright, class. So when there is an imbalance, okay, imbalance. Alright. So in most instances, there is an affected organ. Diba? There is an affected organ. And take note that the affected organ cannot compensate for itself. Okay, so sige, let us give an example. So say for example, there is a metabolic, okay, there is a metabolic, by the way class, this is otherwise referred to as your non-respiratory acid-base, AB na lang ha, acid-base imbalance. Okay, so what are the things that we have to take note of? So take note that the affected organ, okay, so the affected organ in your metabolic or non-respiratory acid-base imbalance is your kidneys. Diba? Is your kidneys. Is your kidney. Okay? Affected organ is your kidney. So that means the affected substance, diba? The abnormal, lagay natin ha, abnormal concentration or the substance with abnormal concentration would be our bicarbonate. Okay, abnormal concentration of your bicarbonate. Okay, so since your kidney is the one that is affected, diba? Is the one that is affected, it cannot compensate for itself because if it is defective, how can it efficiently compensate itself? Siya nga yung may problema eh, 'di ba? Ayan, siya yung may problema, so hindi pwedeng siya ang mag-compensate sa sarili niya. Your kidneys or in general, the affected organ cannot compensate for itself. And so since we only have kidneys and lungs as the organs for acid-base balance, then automatically the compensatory organ would be your lungs. Diba? It's your lungs. So what will your lungs do? So remember that the substance that your lungs can modify is your carbon dioxide. So basically, yes, it has the capacity to modify the partial pressure of carbon dioxide inside the body. Right? Yes. Okay? Ayan. So, yes, let us metabolic, non-respiratory. Ayan. So, say for example, ha, yes. So, tapos na tayo, right? So, say for example, hindi pa tayo tapos. Say for example, our problem is metabolic alkalosis. So, metabolic alkalosis, and then the other one, metabolic acidosis. So, these are acidosis. These are examples of imbalances that are metabolic or non-respiratory in nature. Okay? Yes. So, in the case of your metabolic alkalosis, what is our problem here? So, sabi natin, there would be an abnormal concentration of your bicarbonate. So, specifically, since bicarbonate makes your body alkaline, so in metabolic alkalosis, you would have an increase in bicarbonate. Tama? You would have an increase in your bicarbonate. So in the case naman of your metabolic acidosis, so since your bicarbonate or the absence of your bicarbonate will make your body acidic. Nakuha? Kasi nga, ang bicarbonate, ginagawa niyang alkaline yung katawan. So kung wala kang bicarbonate or kung decrease ang bicarbonate mo, then you are in a state of acidosis, particularly metabolic acidosis because it involves your bicarbonate. So a decrease in your bicarbonate is seen in or will cause rather metabolic acidosis. Okay? So what would be the response? Diba? What would be the response of the body? So the response will come from your lungs. Tama? So since alkalosis siya, do you need carbon dioxide? Yes, of course, you need carbon dioxide. Tama? So the response is to conserve. Okay? The response is to conserve carbon dioxide. Okay? So do not breathe or breathe slowly, right? You breathe slowly, which we usually refer to as your hypoventilation. You conserve carbon dioxide via hypoventilation. So you breathe, breathe. Okay, you breathe slowly. Tama, hypoventilation. All right, next. So let's talk about your metabolic acidosis naman. So in metabolic acidosis, again, it will be your lungs which will respond to this particular abnormal condition. So what should your lungs do? What should your lungs do? Expel, diba? Carbon dioxide. So how will you expel carbon dioxide? You breathe more. You breathe fast. Breathe talaga. You breathe. Nakalimutan ko na, 'di ba? Ano-ano na, halo-halo na. Okay. Huminga ka ng mabilis, right? You breathe faster. Yes, and we call that mechanism hyperventilation. Okay, yes. Hypoventilation for your metabolic alkalosis to conserve carbon dioxide. Hyperventilation for your metabolic acidosis to expel more of your carbon dioxide. Okay? Yan. So yan naman ang ating metabolic or non-respiratory acid-base imbalance. Okay, sige. All right. So let's move on naman to the other one. Okay, to the other type of imbalance, and this is, or this would be your respiratory. Okay, respiratory acid-base imbalance. Okay, yes, so respiratory acid-base imbalance. So what is the affected organ? What is the affected organ in this case? It would be our lungs. Okay, our lungs. And if you're going to look at the concentrations of your parameters, the abnormal concentration or the abnormality rather lies in the concentration of your partial pressure of carbon dioxide. For those who had HEMA 1, who had me? No, I did not have me. Okay. For those who were under me in HEMA 1, parang ang pangit. Okay, basta yung mga naging estudyante ko, for those who were my students, okay, yan, better. For those who were my students in HEMA 1, I usually explain this portion in the introduction, di ba? But of course, for the benefit of everybody, I will explain so that para hindi kayo nagugulhan class. So when we say partial pressure, basically it is merely the concentration of your carbon dioxide. Okay, so remember that since your carbon dioxide, your oxygen, they exist in gaseous form, even inside the body. Yeah, totoo naman yun. They can exist in their gaseous form inside the body. Can we quantitate gases? Yeah, we can. Can we quantitate gases? I mean, is it proper for us to use concentration? No. You have to make use of partial pressure because that is what we are measuring. The partial pressure of your gases, so this will now be correlated to their concentration. And if you're going to look at the correlation, so they are naman directly proportional. So that means if your partial pressure is high, then that means the concentration of your molecule or your substance is also high. Ganun lang naman siya. So in order to quantitate the concentration of gases inside the body, we make use of partial pressure. Okay, the pressure of gases inside the body. Okay, so abnormal concentration, or the abnormality lies in the concentration of your carbon dioxide, okay, or the partial pressure of your carbon dioxide, okay? So if, for example, the affected organ are your lungs, then we cannot use it as the compensatory organ, diba? It cannot be used as the compensatory organ because, katulad nga ng sinabi ko, if it is the one that is defective, then how can it compensate for itself efficiently? No, that organ cannot do that. So the compensatory organ, therefore, in the case of your respiratory acid-base imbalance would be your kidneys, okay? It would be your kidneys. That's a compensatory organ. So kidneys will compensate for the presence of a respiratory acid-base imbalance by modifying the concentration of bicarbonates. Okay, by modifying the concentration of your bicarbonates. Okay, iyan. So what are the different imbalances under respiratory? So it's similar. Yeah, so we have first your respiratory alkalosis. Okay, we have first your respiratory alkalosis. So what basically, ano ba ang something wrong sa respiratory alkalosis? So remember that in respiratory alkalosis, there is decrease in the concentration. There is decreased concentration of the partial pressure of carbon dioxide. Okay, decrease in the partial pressure rather of your carbon dioxide. Okay, so remember, di ba, your carbon dioxide makes your body acidic. So meaning if it is deficient, diba, if there is a deficiency in your carbon dioxide, or if there is a decrease in the partial pressure of your carbon dioxide, then this will lead to alkalosis. Okay, so this will lead po to alkalosis. So what should be the response? Okay, what should be the response of your body? The response of your body is that it should excrete, di ba? Excretion of bicarbonate. Okay, excretion of your bicarbonate. Or, kasi, how would your body ba, or what happens ba in your kidneys? Ano bang nangyayari sa ating renal tubules? Diba, remember that your renal tubules, there is actually a better term for it aside from this. So remember that your renal tubules, they are supposed to reabsorb, right? They are supposed to reabsorb bicarbonate. They are supposed to bring bicarbonate back to the circulation so that the circulation will be able to maintain its slightly alkaline pH. Okay? So, in short, specifically, what is the response, Garod? The response, therefore, should be a decrease, di ba? Decrease reabsorption. Decrease reabsorption of bicarbonate. Okay, decrease in the reabsorption of your bicarbonate. Then, why did you write, Madam, excretion? Because some books would actually say excretion of bicarbonate. Okay, yes. So if, for example, decrease in reabsorption of bicarbonate is not among the given choices, then look for excretion of bicarbonate. Okay, so yan. So another, we have respiratory acidosis. Okay, so what is respiratory acidosis naman, or what is, what's wrong in respiratory acidosis? So there is an increase in the partial pressure of your carbon dioxide. Okay, there is an increase in the partial pressure of your carbon dioxide. Then what should be the response of the body? What should be the response of the body? Your body should increase, di ba? Should increase reabsorption of your bicarbonate ion. Okay, increase reabsorption of your bicarbonate ion because bicarbonate will make your body alkaline. And so, it will counteract the acidity, diba, of your body or the respiratory acidosis of your body. Okay? So, in respiratory alkalosis, there is already an alkaline environment. So that's why your kidneys should decrease reabsorption, because if you are going to reabsorb bicarbonate ions, then it will make the body more alkaline. So it will, make the alkalosis worse if you are going to reabsorb your bicarbonate. Okay, so in the case naman of your metabolic acidosis, okay, so you have to expel your carbon dioxide because your body is in an acidic state already, diba? If you don't expel more carbon dioxide and it will just stay inside the body, then it will make the body more acidic. Okay? Yes. So for your metabolic alkalosis naman, so remember that the problem is alkalosis. So that means you need carbon dioxide in order to counteract the alkalosis inside the body. Okay, di ba? Kasi carbon dioxide will make your body acidic. So to counteract your alkalosis, you need to conserve carbon dioxide. Okay? Ayan. So another po, yes, another. Take note that when it comes to compensation, yes, when it comes to compensation po, ayan, mahirap pag-usapan ng compensation. Okay, hindi, madali lang to, promise. Alright, so remember that the compensation that is made by the lungs is immediate. Okay, so your acid-base imbalance will be immediately compensated. Okay, your metabolic imbalance rather is immediately compensated by the lungs. However, okay, take note that this compensation that is provided by your lungs is short-term and it is incomplete. Okay, so it is short-term, immediately short-term, immediate, short-term, however, it is immediate, however, it is short-term and incomplete. Okay, so in the case naman of your kidneys, yes, your kidneys tend to provide a slower compensation or compensatory response. So it would usually take 2 to 4 days, okay, for the compensation of your kidneys to be complete. However, yes, even if it is slower, the effects, diba, the effects of the compensation is long-term. Yeah, the effect rather of the compensation is long-term and it is complete. Okay, so ano ang pan natin dito? Take away natin dito. So better pa din if you take it slowly, di ba? At least it will be long-term and then it will be complete. Okay, ayan. So another, di ba, madali lang namang huminga and then you constantly you constantly breathe. So that's why the response provided by your lungs is immediate. Okay, alam namang di ka huminga, diba? Your kidneys naman, this is affected by the perfusion of blood. Okay, and especially if, for example, there is a need to provide a higher degree of compensation, so it would usually take slower. Okay, ayan. Sorry. Okay, so another, yes, I will be also providing, ayan. O, di ba? Wala na, hindi nyo na nakita. So, i-rewind nyo na lang. So another important thing that you have to remember when it comes to compensatory mechanism, so full compensation class. So full compensation, we would be able to see a full compensation if the pH is normal already. Okay, if the pH is normal, then it means that the acid-base imbalance has already been fully compensated. Okay, so say for example naman, it is merely a partial compensation. Okay, so in the case of your partial compensation, pH is approaching normal. Okay, so this is what our reference tell us. In partial compensation, the pH is approaching normal. Okay, hindi pa lang nila sinabi na abnormal, di ba? Yeah, because that is what they are trying to really tell us, di ba? When pH is approaching normal, so in short, the pH is still abnormal. Okay, so if you are going to look at no compensation naman, okay, no compensation, pH is abnormal, yeah, if there is no compensation. Ma'am, how would we know if, for example, the set of values given, yes, the set of values given for the parameters, we have pH, partial pressure of carbon dioxide, or ano pa yung isa, concentration of your bicarbonate. How would we know if, for example, the patient is already fully compensated, partially compensated, or if there is no compensation at all? Okay, so paano kaya natin malalaman? Ayan. Anong pangalan nito? Paano po kaya natin malalaman na gano'n? Alright, so of course, you have to know, yeah, class, you have to know the anong pangalan nito? You have to know the normal values of your pH. Okay, of your pH. What is the normal value again of our pH? pH normal value is equal to 7.35 to 7.45. Tama? Okay. And then, ang next na isulat nyo ay partial pressure of carbon dioxide agad, because the partial pressure of your carbon dioxide is merely 35 to 45. So you don't have to memorize much, di ba? Kasi it is just your pH. You just remove the 7. So 35 to 45 millimeters of mercury. Okay, and then another one would be the normal concentration of your bicarbonate. So normal concentration class of your bicarbonate, okay, normal concentration po of our bicarbonate, we have 22 to 26 millimoles, okay, millimoles per liter. Ayan. So pH 7.35 to 7.45, carbon dioxide 35 to 45 millimeter mercury, and then bicarbonate 22 to 26 ito ha. I'm sorry, nagkamali ako. Agad-agad. 22 to 26 millimoles per liter. Okay. So full compensation class. Ayan. So when we talk about full compensation, only the pH is normal. Yes. The other two, ang normal lang class, ang normal lang dyan ay si pH. Okay? The other two parameters are abnormal. Because remember, di ba? Remember, there is a defect in one of the parameters. Diba? If, for example, the problem is respiratory acidosis, then your PCO2 is abnormal, right? So what will your bicarbonate do? Your bicarbonate will compensate for that abnormality in your PCO2. So say for example, for example, originally, ang naging okay. Originally, the problem is respiratory acidosis. Okay? And so, yes, and so, you will have abnormal, 'di ba? An abnormal increase in your PCO2. So ang magiging PCO2 natin, say for example, increase in your PCO2 because respiratory acidosis nga. Tama? Yes. In the presence of respiratory acidosis, what will your kidneys do? Your kidneys will reabsorb more bicarbonate. Okay? So in this case, since it is respiratory acidosis, the response of the body will be to increase, diba? Reabsorption. Diba? Increase reabsorption in your bicarbonate. And so, what will be the value of your bicarbonate? It will be abnormal. Okay, PCO2 is increased because it is respiratory acidosis. Bicarbonate will have an increase in concentration in order to compensate respiratory acidosis. However, if you're going to look at the pH, it is already normal. Okay, so what is this? This is full compensation. The pH is normal. Alright, so yan. Sige, balik naman tayo when it comes to balik naman po tayo dito kay partial compensation. So in the case of your partial compensation, okay, in the case of your partial compensation, everything is abnormal. Yes, everything. Alright, so everything po is abnormal in partial compensation. Ako ha, your pH is abnormal because, yeah, it is still approaching normal. And then of course, the original imbalance is still there. Yes, so that will make the variable or the parameter abnormal. And then your the compensatory mechanism will make the other variable abnormal also. Okay, so I repeat in partial compensation, all values are abnormal. All right. So in the case in which no compensation is done by the body, one parameter is normal. Okay, one parameter is normal. Okay, wait, ilagay natin. For partial compensation, all right, so for partial compensation, all abnormal. Okay, all are abnormal. For partial compensation, all are abnormal. So in the case when there is no compensation at all, okay, so if there is no compensation, pH is abnormal. pH, okay, is abnormal. Okay, pH is abnormal. And then, wait lang. Mas maganda pag ang abnormal would be your pH plus one parameter. Okay, the other parameter is normal. Normal, other parameter. Okay, so say for example, if it is a respiratory acidosis, okay, so of course, as expected, your the partial pressure of your carbon dioxide would be abnormal. But since there is still no compensation, then the concentration of your bicarbonate will remain to be normal. Okay, so ganun lang po. And then, please do not forget that when we talk about when we talk about the measurements, marami ding nalilito dito eh. When we talk about the measurements of your acid-base balance parameters or acid-base ABG as blood gas, arterial blood gas analysis. Okay, I'm sorry. Arterial, we call it in the laboratory, we call it your arterial blood gas analysis. Okay, so for the parameters included in your ABG, ayan, so remember that there are only three. Okay, there are only three parameters that are directly measured. We have your pH, Okay, the partial pressure of your carbon dioxide as well as the partial pressure of your oxygen. Okay, as well as the partial pressure of your oxygen. And then take note also that when it comes to the measurement of your pH, your PCO2, and then your PO2, we take use of different electrodes. So the electrode for pH is glass. The electrode for your PCO2 is otherwise referred to as your Severing-House electrode. And then for your PO2, we call it your Clark electrode. Some references kasi, they include E in the spelling. So it's either Clark with an E or without an E. Okay. So take note, class, that in the case of your arterial blood gas analysis, your HCO3, okay, your HCO3, so this is a calculated, diba? A calculated parameter. Okay, so this is, we do not measure po your bicarbonate. Okay, ayan, we do not measure your bicarbonate. All right, so yung iba sa ano na lang. Ala, sabi ko pa man din 30 minutes. Okay, so anyway, this is the discussion for our acid-base balance. So I do hope you learned something. Bye. Bye. I do hope you learned something. Bye.